Bismillah ar-Rahman ar-Rahim. Let's do this problem. Find the absolute extrema of the function hx. 4 over x squared plus x on 1 to 4. Okay. So let's put the function hx, h as a function of x, equal 4 over x squared plus x. So you need to find out the absolute extrema of the function. Okay, let's find the derivative of hx. So let's find the derivative of hx. Okay, so the derivative of hx, 4 over x squared plus x. So the derivative of hx, h dash x, this is equivalent to this, 4x minus 2, if you take the x squared up, plus x. So this is going to be the minus 2 times 4, that is minus 8, and minus 2 minus 1, that's x minus 3. This is the derivative of 4x to the minus 2. And x is the derivative of that is 1. So the derivative of x is 1. So what is the answer? So minus 8 over x third to the 3, because this is cube, plus 1. That is h dash x. Now this is the derivative of hx. Next, we have to find the critical point by making h dash x equal to 0. Okay, so now we need to find out the critical point. By making h dash x equal to 0. Okay, so let's make h dash x equal to 0. Minus 8x cubed plus 1 equal to 0. And that's going to make it, if you take the minus 8 the other side, so it's 8 over x cubed equal to 1. And then if you multiply x to the third both sides, so it's 8 equal x third. Okay, so now x, if you take 1/3 one side, and x, the 1/3 the other side, so it's 8 to the power 1/3. If you do this into your calculator, you're going to find this as equal to 2. So the answer for this is 2. Which means, what is the meaning of x equal to 2? X equal to 2 is inside this interval. Let's say he said that he wants the extrema, absolute extrema on this interval, 1 to 4. So 2 is inside 1 to 4. So right now, so x equal to 2 is in the interval of 1 to 4, because that's what he wants you to get it, 1 to 4. Okay. Which means that x equal to 2 is the critical point. Now, let's evaluate hx at the critical point. Now, let's go for the lowest point, x equal to 1. And look, this is the left endpoint. And find out the function as a function of 1. As a function of 1. Okay, so what is the equation? It is minus 8. This is the equation that we're going to be dealing. This is not hx. Sorry. We have to go for hx, not h dash x. What is h dash x? Okay, so it's here. Sorry, this is the hx. That's not the derivative. So it's So it is 4 over x square, and now we're going to put 1 square plus 1. We're going to put x equal to 1 instead of x. That will give you 5. What is the meaning of this? At x equal to 1, the function h is equal to 5. Okay. This is the absolute maxima at x equal to 1. Let's look at the critical point. At the critical point, which is x equal to 2, the function of, as a function of 2, it's 4. Again, it's x squared, which is 2 squared plus 2. It is 4 over x squared plus x, and that will give you 4 over 4. It's cancelled. It's 1. 1 plus 2, 3. So now at x equal to 2, the function h is equal to 3. Okay. Now let's look at the last interval, the right interval, the right endpoint, 4. So at x equal to 4, the function as a function of 4 is equal 4 over 4 squared, because it's x squared plus x, and that is 4. So 4 over 4 squared, which means 1 over 4. So it is 4.25. Okay. This is the function h as a function of the right endpoint 4. Now, after this, we have to determine which one of those value, which one, the 5, and the 3, and the 4.25. We can see that the absolute maxima is here. This is the absolute maxima. So the absolute maxima maximum is at 5, is 5, the point 5, and that is at x equal to 1. Ooh. Let's do it again. The absolute maximum is 5, is the point 5, number 5, and that is at x equal to 1. That is the absolute maximum. What is the absolute minimum? Well, this is the minimum, 3 out of 5, and 3 and 4.25. Minimum is 3. So the absolute minimum is 3, the number 3, and this is at, of course, at x equal to 2. Okay, so now we have both the absolute maximum for that function, and we have the absolute minimum. Absolute maximum at 5, at x equal to 1. The absolute minimum is 3 at x equal to 2. This is the way we solve it for number 5, the absolute extrema for the function hx. Okay, I hope that this is easy to understand.